Aloha kako. As Mahealani said, my name is Athleen Clark, and I'm the NOAA Superintendent for Papahānaumokuākea. Papahānaumokuākea is co-managed by 7 different agencies and includes NOAA, Fish and Wildlife Service, State of Hawaii, and Office of Hawaiian Affairs. So it is in fact an area that is managed both for its biological richness and biological diversity, as well as its cultural richness and its cultural diversity. And for those of you who don't know, it was recently expanded by President Obama and is now the largest marine protected area on the planet at nearly the size of Alaska. And it is also a UNESCO World Heritage Site, which was designated in 2010. So it's one of 2 World Heritage Sites in Hawaii. I would like to take this opportunity to introduce Dr. Chris Kelley, who's with the Hawaii Undersea Research Laboratory and has been working with us in Papahānaumokuākea before it was even Papahānaumokuākea. Chris's research spans many years up in the monument and has been one of our key advocates for both identifying and discovering new species and habitats within the monument, but also trying to discuss why they're so important in terms of their conservation value. So without further ado, Chris.
Where did the name Papahānaumokuākea come from?
We had a Hawaiian cultural working group that worked on coming up with different names, and it was actually finally decided by the group, but the lead author for it was Pua Kanahele.
Can you just say what the current status is of the National Monument and the prospects now with the Trump administration?
It's so new, we have no idea. And we know that there's going to be a review of the process for all of the monuments that were designated in the last 21 years. However, the public process for Papahānaumokuākea was extensive. So, one of the concerns was public process. We can tell you unequivocally that when we started down this road in 1999, and from there on, the process has been extensive. There's just before the expansion, we had over 57,000 public comments. So what that means in the long run remains to be seen, but we think that we stand on relatively firm ground.
Actually,
Let's go to Chris. I'm sorry, I need.
On that same note, what's the current status of the fishing industry in trying to trim down the size of the monument?
Again, the advocacy for this started with the fishing industry. So, we'll have to wait and see what the actual review determines. That's all I can tell you. Is it's too new to say anything more than that.
Thank you.
Thanks, Kathleen. So I think this is working. Yeah, sounds like it. All right. Well, thank you very much for coming. This is not a solo effort. Obviously, if you look at the acknowledgements, there are a lot of agencies that are involved in exploring the deep resources in the monument. And so, as you can see, the university, the monument itself, NOAA Office of Ocean Exploration, and Schmidt Ocean Institute, believe it or not. And those of you who don't know that, that's the Google Schmidts that actually created a foundation that's actually supporting a lot of ocean research right now. So it's really marvelous of them to do that. Okay, so many of you probably know what the Hawaiian archipelago looks like, but I'm just gonna maybe just do a real quick refresher here. Here's the main islands right down here, and actually these main islands are the very sort of latest or newer islands in a very, very long string of volcanoes that goes all the way up to the Aleutian Trench right here and disappears underneath that particular plate. So essentially, I think most of you also probably heard that the Hawaiian Islands were formed via a hotspot. There's a single plume, if you will, or a localized plume in the mantle, and this area right here, oops, I pushed the wrong one, okay. Guess I gotta go this way. Nope.
Just turn out the
Tell you what. Yeah. That's right. Okay, there we go. So what I'll do is I've got to get used to this without my glasses. I should probably have my glasses on too. Anyway, so these volcanoes are believed to have been created in sequence, with the oldest ones being around 80 million years ago, somewhere in the mid to late. Why am I doing that? Okay, we're going to cursor mode here. Okay, this is better. So with the oldest one being around 80 million years old, that's sort of late to middle Cretaceous. And then down here off the island of Hawaii, they're still being formed with the Lauihi undersea volcano right there. And this will continue well beyond our passing and for thousands, if not millions of more years. So this is a really important archipelago. It actually has given geologists an idea of how the Pacific plate has been moving for the last 80 million years. And if you notice, there's quite a little bend in it right there. And they believe, there's a couple of different theories, but there's one belief that the plate actually changed direction when India crashed into Asia, and that's what caused that, but who really knows? But in any case, the point is that we're part of a very long chain of volcanoes. Oh, sorry. All right. I'm getting it. Here we go. All right, just want to show you the kind of track that we think occurred to form these seamounts and volcanoes. And this is the old boundary for the Papahānaumokuākea Marine National Monument. And one of the interesting points I'm going to make this evening, I'm going to talk a bit about geology and then I'm going to get into biology, is exactly what the expansion of the monument actually captured. So the old monument was predominantly Hawaiian volcanoes, and it was restricted to 50 miles on either side of these emergent atolls, as well as seamounts from just right across a little bank between Ni'ihau and I believe it's Nihoa or Necker. I'm trying to remember which one it is. It's called Middle Bank, and it goes up past Kure Atoll. And the reason I brought this slide up is that we tend to think that we're out in the middle of the Pacific here, because when you look at when we're on the surface, we're the only thing out here. But when you go down deep and you go to the seafloor, we've got a lot of neighbors down here. We're not the only seamounts or volcanoes in town. And this is showing you a number of these. And I'll see if my big fingers will be able to operate this right. The mid-pack mountains are this big whole mound of mountains right here. There's something called Necker Ridge that goes right up close to Necker Island. You've got the Musician Seamounts over here. Liliuokalani Ridge is the seamounts running down here. There's a tiny little one you can't see very well called the Wentworth Chain. This flat area right here is called the Hess Rise, and then here's the Emperor. So the Hawaiian volcanoes are essentially go up to right around the bend, and then they are considered to go into what's called the Emperor Chain, even though they're all the same thing. Okay, so we got a lot of neighbors, and we're the newest kids on the block here in Hawaii. All of these neighbors are really old. And some of these actually are believed to date back close to 100 million years, so mid-Cretaceous period. So up until 2014, there's fairly good resolution seafloor data in the lower part of the monument, but a lot of the seamounts in the northern of the previous seamount boundary, the northern end of it, were not all that well mapped. And so we were able to get a grant from the Schmidt Ocean Foundation, who provided its ship, the Falcor, to go up there and spend 72 days and really map out some of the northern seamounts that were inside the monument itself. And this is a look at some of the data. We mapped all of these seamounts that you can see right here. They used to be kind of blobs because they were based on satellite altimetry data. That was the best type of look we had at them. But after we were able to spend this time on the Schmidt boat, we got some fantastic imagery of the seamounts up here. And the point I want to make here is, well, it's going to come out of taking a look at two particular seamounts that I'm going to point out that look kind of nondescript. The one in the upper left is called the seamount east of Salmon Bank, so I'll just call it East Seamount. And then the other one to the right of that is called Bank 9. And let's start with East Salmon, and I'll call it East Salmon Guyot because these are the first deep guyots that were discovered essentially in the monument. And by guyot, what I'm talking about is it's a seamount that has a flat summit. And it gets that flat summit because at some point it was at the surface. It used to be an atoll. It used to probably be an island. Then through erosion and subsidence and reef growth, then it all kind of flattened out the top. And then eventually the thing sank down into deep water. But here's the deal. The top of this particular seamount, the flat summit, is around 1,500 meters down. So there's a lot of these guyots in the Hawaiian archipelago, but they're about 80 to 100 meters down. So this particular guyot, which was at the surface, is really deep, and it took quite a while for it to get down there. Okay, so we immediately started suspecting that these are Cretaceous features that are in somewhere mixed in with the Hawaiian seamounts as well. And I actually went back into some old data, and as it turns out, some of these seamounts were dredged before it became a monument, and they did find some rocks, and they dated the rocks back to the Cretaceous period as well. The thing about dredges is you're not really sure where the rock came from, and the underlying seafloor is on the neighborhood of 100 to 120 million years old, so it could have just come from some seamount feature next to some rocky feature next to the seamount. And then we mapped this one, and this is called Bank 9 right now. We're hoping to actually name this thing perhaps after Wendy Schmidt, who provided the resources to map this thing. And this is a really weird seamount. And the reason being is that it's got a very high flat summit right here that's typical of Hawaiian seamounts or volcanoes that were at the surface, and now it's sunk down about 80 meters or so. And then it's got this other one that's really deep down here. It's got two different ones, and there's no terraces in between the two of them. And at first when we saw this, we're just shaking our heads and scratching our heads going, what the heck is going on here? And I'll show you what we think is going on here. And I'll get to your question in a second. And to make the point, this is the seamount. Keep doing that. All right. That's the seamount we just looked at, East Salmon. And if you look at the similarity between that seamount and the southern part of Bank 9, it's almost unmistakable. They're almost identical. Finally, we had one of these eureka moments. Bank 9 is not a single seamount. It is two seamounts. It is a Hawaiian seamount that erupted on the northern side of an older Cretaceous seamount that was already on the floor. This older part is believed to be about 82 million years old, and the Hawaiian seamount we're not really sure of, but it's going to come out because there were rock samples that we took there at around 25 to 30 million years. So these two parts of the seamount are spaced in time by almost 60 million years. And it's it's a very unique seamount because you just don't get these type of things out there. And so this is actually the subject of a publication. We published this in EOS Journal a couple years ago because it was such a unique finding. So then we started taking a look at everything, and now we understand that there are Cretaceous seamounts mixed in with the Hawaiian seamounts. So how did that happen? And all these ones that are circled, I'm reluctant to even grab this device, which is biting me here. All these ones in the black circles we think are all older Cretaceous seamounts. And all these ones in the red squares we think are Hawaiian seamounts. Okay, and so how did this happen? Where did these things come from? And why are they all mixed up here? Well, what we think happened is this. The Wentworth chain of seamounts supposedly only came down to about here. Okay, but now what we're thinking is these other ones, these new ones that we found Bank 9, and perhaps these down here represent a longer Wentworth chain, that the actual old chain goes much further south than was previously thought. And this chain would have formed like this, would have come down like this, millions and millions of years going down like this, and then it petered out right about here. And the Hawaiian volcanoes were coming down like this, and they crossed right through the Wentworth chain, and you've got a mixed seamount area up there, which makes that area really interesting. I want to show you a video here of how we think this happened. And the white you'll see is the Hess Rise and the Wentworth Range. and then you'll see in yellow the Hawaiian range. So here's Hess Rise, and here's the Wentworth and Liliuokalani seamount chains forming 70 million years ago. Here comes the Hawaiian seamounts. And then there's the bend, and then it intersects right across the Wentworth chain. They never would have intersected if it wasn't for that bend. They never would have intersected if the direction of the Pacific plate hadn't changed between when the older chain formed and the newer chain formed, which is pretty darn cool, if you ask me. Okay.
What's the depth of the Pacific plate in that area?
Depth of the Pacific plate is somewhere between 4,500 and 4,500 to 5,000 meters deep. So if we look at some of these other ones too, looking at some reference, here's the Liliuokalani chain. Looks like this is coming down here. Here's in the Musician seamounts, another chain. They actually dated these, and this is indeed a hotspot chain. So there's actually perfect lineation here between these three chains of really old seamounts that are all about the same age. They're all formed as the Pacific plate is moving in this direction. And then it changed direction, and the Hawaii seamounts formed at a little different angle.
Why the name Musician Seamount?
I have no idea, but the seamounts are Brahms and Mozart and whole bunch of different things. I have no idea. Okay, so that's kind of the picture that I wanted to show you here. I'm going to throw out one last one on the geology, and we'll get to the biology. But first, here's the new expanded area of the Papahānaumokuākea Marine National Monument. And the thing I want to point out is that in terms of Hawaiian seamounts, the actual expansion captured just a few right up through here. But what it did is it captured a lot of these really older seamounts. So now the monument isn't just Hawaii islands and Hawaii atolls and Hawaii volcanoes. Now it's got a whole lot of interesting things in it. It's got this marvelous weird ridge, and don't ask me how that formed because I have no clue. And then it's got some of these other seamounts. And then it's got some sort of anomalies here, this one here. And the way you think about these seamount chains is you think about how they line up. So you've got sort of this line going this way that's parallel to the Hawaiian chain. And then you've got this one that's kind of going sort of vertical right here. And I mean, seamounts don't split. Hotspots, maybe they split, but I don't think so. So I'm going to throw out a little hypothesis here. It's probably completely wrong, but it's kind of fun to think about this stuff. And that is, if you take a look at those two that I was just pointing out, those two areas, what if, this is a big what if this particular bunch of seamounts formed right about here, and then it did a turn like this, right about in here, and while this part of the Hawaiian archipelago was forming, this part of this particular chain was forming too. So you actually have two parallel hotspots. It may be bull, it may be correct, I don't know, but we're going to go up and we're going to be sampling the very end here, these two seamounts here, this July. And if we're correct on this, then these two ought to be around 30 million years old. They shouldn't be 60 or 80 million years old, and they would be roughly equivalent to the age of these Hawaiian seamounts right in here. So it should be an easy hypothesis to test. But anyway, it's just to get you thinking about all the seamounts in the Pacific, what's on the seafloor in the Papahānaumokuākea Marine National Monument, and then look at this mess. These are records of seamounts that formed over more than 100 million years old. These are over 100 million years old, and goodness knows exactly what happened here and how many crisscrosses you have here. But the seafloor, the deep seafloor, is very, very interesting geologically. Okay, we're going to switch, and we're going to talk about biology. Hawaii Undersea Research Laboratory here at the University of Hawaii has got a couple of manned submersibles that can go down to 2,000 meters, and they started working in the monument. Good grief, I think. Well, before it was a monument, they were up there, I think, in the 1980s. I think Ricky Grigg was first up there for that. Yeah, okay, so it's before that. So they've been up there for quite a while. And they're still going up there, even though they're kind of suffering on the funding front. They're still going to go up there and do some work up above the Papahānaumokuākea Marine National Monument. And so manned submersibles have been used to explore the deep seamount in the monument. But also, as of 2 years ago, the Okeanos Explorer, which is a NOAA ship, also came and started doing some work. And in 2015 and 2016, they did 2 cruises in the monument using this particular ship. And it's one of the things I want to point out. This is not a manned submersible. There's nobody inside of this vehicle, which is deployed off the back deck here. This is what's called a remotely operated vehicle. So there are actually pilots that are directing it from inside the ship. This remains cabled to the ship. And they control it, with sort of joysticks, rather sophisticated joysticks. Interesting thing about the Okeanos Explorer is that it has a satellite dish here, and it transmits all of the dive video in real time over the internet. So anyone can log on. And they're diving right now in the Jarvis Monument, and had a really good dive today. And yesterday they were in the Cook Islands and had a fantastic dive. A lot of deep sea corals. You guys are interested? If you are, you can go and Google Okeanos Explorer. You'll see a link to live video. They're going to be diving off of Jarvis Atoll tomorrow. So you can take a peek. Okay, this is kind of a summary slide of all of the submersible and the manned submersible and all of the ROV dives that have been done to date in the monument. And obviously, since this expansion is quite recent, it was actually about a year ago, right, Kathleen? Not even a year ago, right? Okay, most of the work was concentrated in the older boundaries. That was the focus. And you can see only recently, this last year, there are a couple dives done outside here. And then this is an earlier cruise back in 2011 that wasn't really targeting the monument. But that's it. Nobody has ever dove on these seamounts or these seamounts or these seamounts or even some of these Hawaiian ones up here as well. This is one of the Wentworth seamounts. None of these have ever been dove on before. So there's a lot of work to do here. And even though a lot of the features in the expanded monument, some of the newer features that are now enclosed in the monument aren't very well understood, I want to show you some of the things we have found out about the monument. Starting first, consider the most spectacular finding, and that is that both in the old and in the new monument, there are some incredible communities of deep water corals and sponges about 2,000 meters down. That's about 6,000 feet down. Pressure down there is greater than the inside of a 3,000 PSI scuba tank. It's absolutely jet black, and it is freezing cold on the order of 1 to 2 degrees centigrade. Yet, there are incredible animals all over the seafloor. There's life at every depth. That's not what I'm talking about. I'm talking about communities that are so dense here that you have to be careful to even find a spot where you can set your vehicle down momentarily to collect a sample or something here. So you have these, and they're all different. As you can see, they're very, very different types of corals, different types of sponges. These are these big glass sponges here. And here's the thing. There's one of these communities off of Pioneer Bank, and it's off of a ridge coming south of Pioneer Bank. And there's been 2 submersible dives and 2 ROV dives at different points along that ridge. And all we know right now, we have not been able to find either the upper or the lower extent of that community. And we've surveyed in different locations over 22 kilometers in length. And this entire length of this community that's it. This is the kind of densities of corals you're seeing. So sometimes I like to refer to these communities as deep sea cities because they literally are bigger than Honolulu and bigger than most of the mainland cities as well. Pioneer is about 2/3 of the way up in the monument. It's, let's see, it's going to be a little bit southeast of Laysan, I believe, and it's going to be northwest of what? What is it? Gardner, yeah, thank you, Gardner. Only in the monuments? Are they only on Hawaiian seamounts? No, this one we found on one of these Cretaceous seamounts, one of the very few that we dove on this last year. They're a rather incredible community, just as spectacular. We don't know how big it is because we just did one dive on it. And this is off of Necker Ridge, this incredible community of sea lilies, or excuse me, these are feather stars, sorry. They're all crinoids. They're in that group crinoids. And they also had quite some corals as well, and these are all different too. So the monument has got some absolutely amazing communities. Okay, now I want to go through a few things, just talking story a little bit about some of the things we found in the monument. We're going to start with the big stories. Yeah, and you know what, some of you may know what this is going to be about. This came out, can't even read the year here. This came out a number of years ago. It was published by Dr. Les Watling here at the University of Hawaii. And this was a type of coral, it's called Iridogorgia. And he published this stating that, and he's a deep water coral biologist, stating that this coral, in his opinion, is the largest Gorgonian deep water coral that's ever been discovered on the planet. And it's 15 feet long. And it's there in the monument, and there's a lot of other ones like this that are down there. And so far, nobody has refuted that. So the Papahānaumokuākea has a claim now to having the biggest Gorgonian on the planet. And then as of 2015, I was out on the ship with Daniel Wagner, who used to work for the monument, and we came across this thing. Now, unfortunately, I knew I was going to forget to ask you to look at the size of the people on that ship shot. And I was showing you the picture of the Oceanus Explorer so you could get an idea how big this ROV is. The ROV itself is huge. It's as big as a manned submersible, and I think it's there. There it is right there. And we came across a sponge that's as big or bigger than the ROV. And I'm going to show you the moment of discovery, which is a little embarrassing because I've got some audio in there. I'm going, let's see, is it the next one? I guess it's the next one. Here we go. Okay.
This looks like the same folded sponge that we sampled yesterday. Look at the size of these things. Oh my goodness, where did this guy come from? Holy cow.
That is
Oh, geez.
Absolutely beautiful.
Bruce pointed out he's not sure which is bigger, the ROV or the sponge. And looking at the Ceros view overhead, I'm not sure. I think it's a tie here.
This is the largest thing I've ever seen underwater.
That's the ROV pilot who's been on hundreds and hundreds of dives. He has never seen an animal that massive in the Atlantic, off of the Indonesia, anywhere, West Coast. Anyway, so Daniel and I got the bright idea, and this is Daniel's primarily because we were rooming together on the ship. You know, let's go ahead and submit this, what the heck, and see what happens. So we whipped up this very short paper and we submitted it from the ship. About a year later, it actually came out in press, and this is what happened. 14,000 news stories later that are internet stories, CNN, NBC. I was doing interviews for Australian radio and Canada, Discovery Channel Canada, and it was just absolutely nuts. And NOAA was keeping track of all of this, and they calculated the ad value from these stories to be about $21 million from a sponge. Go figure.
Why do they call it a glass sponge?
Because the question is, why do they call it a glass sponge? Because it has microscopic parts that are made of silica that look very transparent. And it gives it a very glassy, translucent appearance. This guy's really thick and old, so it's not quite as translucent as some of them. Now, here's a kicker about this sponge. We don't know what species it is, and we sampled it, and we essentially got a small piece, and I'm interested in glass sponges, and I did the microscopy on this, took a lot of pictures, and sent them off to the world's authorities. Not only do we not know what species it is, we don't even know what genus it belongs in. All we know is the subfamily. So one of the largest creatures that has been discovered in the ocean, we have no idea what it is. Brand new. But I think it should be called the Sharpei sponge rather than the news stories called it the minivan sponge because one of us compared it to a minivan. But okay, other new kids on the blocks, and hopefully I'm not getting too close here. I still got time, right? Okay, I'm good. Okay, this was actually a sponge. I'm putting it in here because it was discovered a little bit earlier by HURL, and we used to call this the gramophone sponge. And this was in 2003, and we've since seen a lot of these things. And it's very difficult to differentiate from other sponges, but it's totally bizarre. It's got a little stalk down here and it has this big dish. And if you look at the backside, it looks like sort of a satellite radar array or something like this. And again, there's controversy and there's dispute between the sponge experts in the world, one in Russia and one in Vancouver. One says it's in this family, the other says it's in the other family, and they fight about it. So we don't know what this thing is, but it was discovered in the monument first, and it's going to be a new genus if they ever figure out what family it belongs to.
Size.
What's that?
Size.
About the size of a gramophone, I guess. Yeah. All right. This is not a new discovery. This is a typical tube anemone, although we don't know what species it is because they're really hard to sample. Tube anemones, everybody familiar with tube anemones? They're kind of anemones that are kind of like feather duster worms where they create this little tube. Most of the times they're in the sediment. This one's on a rock here. And then when they get disturbed, they retract down into the tube, and that's their little protective house here, right? And that's what they're called, tube anemones in the order Cereanthidae. This particular tube anemone did not get the memo. He does not make a tube. Not only that is tube anemones are typically small. This guy is enormous. He's probably about this big around. We've seen it in multiple cases. It lives on rocks. It does not make a tube, yet it is absolutely a tube anemone. Again, the world's authority on these animals has concluded for sure that that's exactly what it is. We don't, okay, we've got it to order, but family, genus, species, we haven't been able to collect one yet, but I'm going to try this year, see if we come across one and see if we can grab one.
Does it retract?
What's that?
Does it retract?
Into what? I know, exactly. We don't know what it does, but if we do find one that we can try to grab and put in the box, then we'll find out what it does. Anyway, we need to figure out what this animal is. We've seen it off of the Mariana, in the Mariana Archipelago. We've seen it off of Wake, and I think they might have come across one of these down in American Samoa. So it's around in the Pacific. A really smart crustacean. I call it the rose squat lobster because it has it's very, very beautiful, but it's very thorny. So it was on this black coral right here, and there was quite a discussion. Pictures were sent around about this particular crustacean, and somebody in Europe actually said he thinks it's a brand new genus. He's never seen anything like it. So we've seen them. We know they're down there. In fact, we encounter them every few dives or so at a particular depth. And we tried to collect these, I think now on 3 occasions, and we get them right to the box, and then this squat lobster gets wise, and he bails, heads off, and we never get him. So it is one smart guy. He knows what's about to happen to him somehow. But anyway, new genus of squat lobsters. It's a type of crustacean that lives on corals, and a really, really beautiful little guy. Okay, this is sort of new, but this is kind of what I'm showing you here is a typical deep sea octopus. These are the types of octopuses that are down over 1,000 meters deep. A lot of these really deep water octopuses have cirri or fins, and you can see that right here. That's the fins on the other side, and here's some over here on this particular species, 2 different species. And they use these fins to swim. And we call these things Dumbo octopuses for obvious reasons. Okay, but they use them to swim. Why they can't jet propulse themselves like shallow water octopods, I don't really know. But they use these fins, and so they kind of just, they're very weird. Last year, and we call him Casper. And he was in the monument. He was on one of the first dives we did last year in the monument. He should have fins. Basically, every deep water octopod, if you will, is called cirrate because cirrate means the fins. He's an incirrate octopus, and nobody knows who he is or what he is. And this thing also hit the news, and a lot of people really love this thing. I think Casper's a perfect name, so hopefully if he ever gets named, he'll be Casperi or something like that. New creature right there in the monument. Okay, this is my you are what you eat or maybe not, and I just want to talk a little bit about, always fun, I'm not going to show sharks, by the way. Instead, I want to show some just a few of these, not very many of them. This is a mollusk, believe it or not, and it eats corals. So it's actually cleaned off all the branches of coral here, and he's just kind of spiraling his way up, eating polyp after polyp. Coral, I don't know how long it takes him to eat those. But anyway, I never would have, it's basically like a sea slug that eats corals. So that was a brand new one on me, and this was confirmed by people who study these things. We don't know what species, but we know the genus. Wrong. This is another cnidarian. It's a jellyfish, and he's feeding on one of his relations, which is a coral. Now that's just rude. That's not quite cannibalism. This jellyfish lands on the branch, and they have tentacles like most jellyfishes where they're catching stuff in the water column if they swim by. Instead, he kind of inserts his mouth into one of the coral polyps themselves and just starts sucking it out, kind of like a spider or something like this. And then when that's done, he'll just move to the next one, and he uses his tentacles to hold on coral while he feeds on it. So anyway, that's kind of interesting. Who would have thought that jellyfish landed on corals and ate them? I wouldn't have. All right, I call this one the sponge that thinks it's a coral. So this is a sponge, and it confused us for a while because sponges are blobs, or they can be kind of weird things like that. But you don't see sponges that look like coral fans. But this guy, he must have been watching some of the corals going, hey, look, those guys have got to be getting more food than I'm getting here. Maybe if I kind of spread out a little bit and create this kind of fan-like thing, I can filter the water better too. And that's what he is. We know as Stellodorix. I'm not really in the new species thing anymore, but it's going to be a new species, sure. And it's also a very unusual class of deep water sponges called demosponges. It's not a glass sponge. It's a different type of sponge. Anyway, sponges that think they're corals. Okay, the topic here is relationships between animals. Okay, if you think we humans have got some odd relationships, these guys have got some seriously odd relationships. Okay, I call this the hula crab for obvious reasons. See, there's the button. That's a skirt. This is a pagurid. I think it's a parapagurid, I think it's the correct term. There's no shell under here. This is an anemone, and the anemone actually attaches onto the rear end of this crab. You see this anemone, he's on the crab. Whenever you see the crab, he's on the anemone. You don't see the crab without see the anemone without his crab. I don't know how that works. Does the anemone find the crab, or do they, when they're really young and larval, they become best buds like right off the bat? And I don't know how that happens, but very tight relationship. I call this the anemone sponge. So this is in the monument itself, and the first one of these that we actually confirmed existed in Hawaii was up in the Papahānaumokuākea Marine National Monument. Looks like a vase sponge. It's a glass sponge. Typical, except for this. You look at it really, really closely. It's covered with anemones that are all embedded in it. And in fact, all of these anemones, if you see them in the sponge, it has to be in that genus Lafroyella. You do not see that genus of sponge without its anemones, and you don't, at least as far as we know, we don't see these anemones with this sponge. How does it get started? Every single time we see one of these sponges, it's got the anemones on it. How does that happen? Like, do they somehow synchronize their reproductive larvae so that they all land together? If you thought that the anemones would later, come and land on the sponge afterward, right? Then you'd expect sooner or later you're going to find a sponge that doesn't have them, just by chance. Some anemones just didn't find them yet. Those anemones define that genus. I don't get it. This is the glass sponge. It's a brittle glass sponge. It's in what's called the genus Pharia. What do you guys think all of these white things are here? I suppose by the title, I should have not put that out there. It's a black coral. So there is a black coral that is growing throughout the sponge, and that black coral, as far as we know, grows only on these types of sponges. These sponges without the corals, but a lot of them have got it in there. And that's going to be a new species of black coral, by the way. This is also up in the monument. So how that happens and why that happens and how it even gets started, again, no idea. This is sort of a common thing. This is a Gorgonian coral called Metallogorgia, and here's a brittle star, and it's a very well-known Gorgonian coral, species. And here's this brittle star. It's also very well-known. It's called, I was going to forget it, something or other, Oedipus. Well, anyway, they know what the name of this thing is. Here's the catch. This is one of the few Gorgonian to be, what the right term is, all over the place. It's in the Atlantic, it's in the Pacific, and from genetics, it's the same species, identical. So are the brittle stars. It's the same brittle star, Atlantic, Pacific. How does that happen? How can, I mean, at some point you think that this brittle star doesn't occur in the Pacific, so he's going to get a different brittle star, the Pacific ones. No, it's the same thing. How do these relationships form? All right, then I'm going to show you a few last kind of things here. I can't remember how many more things I've got, but this is the acrobatic snail, and I've got a little video because you can't really appreciate his moves. I once presented this video too. I called it Moves Like Jagger, but I'm just going to call it the acrobatic snail. We found this in 2015 in the monument, and we were astonished. At first, we thought something was attacking the snail because we didn't get what was going on. And then we started looking at it more and more, and then it turns out some of the NOAA fisheries guys actually knew what this snail was from shallower waters. But let me show you what it does. Let's see. There we go.
Okay, interesting.
So interesting.
So how is he moving like that? What is he doing? It's not like, let's see, he's pushing off with his foot.
All right. Just looking around.
The snail is the subject of a recent publication by Dr. Mary Wickstein down in Texas A&M, and she actually coerced me into measuring how far that snail traveled, which was about 3.5 meters before it finally stopped tumbling. So snails tumble, I don't know, escape mechanism of some kind. Real quick, deep sea drones. I'm getting close to the end of my time here. I don't know much about midwater animals. I'm kind of a benthic guy. I just wanted to show you a few of the pictures of things that have been documented in the monument. Incredible jellyfishes like this one. You've also got these siphonophores, and I don't even know how to describe this, but this is another one of these gelatinous type of animals that can get quite large, that are up in the water column as well, above the seafloor. These could be a younger stage of a type of lobster, but this lobster swimming, I mean, how many times do you see lobsters swimming? And I did a video of this swimming, but I didn't bring it tonight. But anyway, this is considered a living fossil. It's one of the very early predecessors of the modern day lobsters. And did you know that sea cucumbers can swim? Well, they do in deep water. They swim, they don't just sit there on the bottom in Kaneohe Bay or in Hanoma Bay looking like blobs on the seafloor. Instead, they are beautiful, elegant, transparent, fascinating animals, and a lot of them swim. And this is just one of them as well. And then they'll settle down and they'll do some feeding and so forth, and then they get bored with where they are, and up they go, and away they go off somewhere else and settle down again. Last couple slides here. Why should you care about the deep sea and what lives there? I love this picture. This one over here on the left. 80%, over 2/3 of the Earth's surface is deep sea. If you don't know anything about the deep sea, you don't even know the planet you're living on. we tend to think that our world is this terrestrial part of this world, and it is not. 2/3 of our planet is deep sea. The real predominant habitat on our planet looks like that. It is dark, it is cold, it is deep, and it is very high pressure. And yet we don't know, we're barely even beginning to scratch the surface of what animals live there on our planet. Right? And here we are going to the moon, and we're going to Mars and talking about all these things, and we don't even know our own planet. That's why you should know something about the deep sea, and you should care. Secondly is, deep sea mining is on the horizon. It is coming. And when it comes, it is going to destroy some of the most spectacular communities that you can even imagine, because these marvelous communities at 2,000 meters, that's the depth where deep sea mining is going to occur for removing manganese crust. There's several forms of deep sea mining, but this is the type where you're actually removing a precipitate that's coating all of the rocks below about 1,000 meters. That's a very valuable precipitate, very valuable mineral-rich crust. And machines are being built now, and plans are being drawn to do this. The race is on. We're not going to stop it. People are not going to be willing to give up cell phones and solar panels and wind turbines, and we are going to run out of our terrestrial sources of these minerals in the future, maybe in 100 years, and it's going to happen. What we're trying to do right now is find something out about where the really spectacular communities are, so we can direct perhaps mining to other places where there are not so many. One more slide.
What is benthic?
Benthic, that's the bottom. Yeah, so the mining here, I just had this made recently. Here's the ship that takes all of the mining materials. It's going to send out a toxic effluent near the surface. It's going to kick up a big sediment cloud. That's your crust, the black, and these machines are just going to grind it off with all the animals on it. It's going to be underwater strip mining. It's going to happen, but we can at least make sure that it happens carefully and responsibly. Manganese crust. The manganese crust is loaded with cobalt, iron, titanium, rare earth metals, copper, everything. And it is a huge untapped resource down below there. So why should you care about the Papahānaumokuākea Marine National Monument? Whoops, doggone it. I blew it there. Okay. It's because give us hope for the future. When you compare how big this is, you think it's enormous. Like Kathleen was saying, it's the size of Alaska, but look at how big it is compared to the ocean here. It gives us hope, and it gives future generations hope that they're going to have something left when they inherit the earth. So thank you very much. Okay. Questions? Yep.
A couple of slides back, you showed a pair of animals that are in both oceans.
Yes.
Can you age those from its DNA?
No.
See if it goes way back when it was on the other one?
No, I mean, they can try to figure out where it is in its place. It's in a group of gorgonians that are called chrysogorgids in the family, or gold corals. And the DNA can reveal where it is supposedly in the tree for that particular family, but that's it. And I don't think I don't really know. Actually, never really thought about how ancient that particular species is. But it's probably pretty old if it's spanning all these oceans. Yeah, sure.
How do these fragile-looking, brittle, gelatinous bodies survive this tremendous pressure?
Good question. So someone else want to answer that? How do the gelatinous bodies survive in all that pressure?
I would guess the inside pressure and the outside pressure, right?
Correct. And how would that happen?
It's the water.
Right.
The whole,
They don't have air spaces. Air is the problem with pressure. Water is almost incompressible, but air is not. So any animal that has air spaces, like a lot of the fish, like Papahānaumokuākea and some of the reef fishes, they have air bladders to maintain their buoyancy. If they're in deep water and you bring them up fast on the surface, they'll just bloat right up because their air bladders expand. And so that's called barotrauma, believe it or not. All of these animals, they don't have air spaces. They kind of equilibrate inside and out, and they're fine.
Did you guys eat any of the crabs and lobsters?
No. Yeah, we don't, well, particularly in the monument, we're not eating. And we're not going to say that with Athleen here that we actually but,
They're delicious. Just get it down.
yes.
And the found have up to 300 feet, you have animals that will change color and texture like octopus for protection. You go down in deep water when there's no light, basically no light. What kind of protection do they have except running away?
Okay, so the question is, some of the shallower water animals can use camouflage to protect themselves. So how about the deeper water animals? Well, first of all, camouflage is visual protection. So when you're down there in really deep water with no light, and you're not producing any light yourself, then you don't need visual protection, but you might need olfactory protection. Somebody might smell you. Somebody might detect you from electric currents. Somebody might, what are some of the other ways that you could be sensed? So some animals, they have very long spines. Some of them can be toxic. Like that snail is how it protects itself. He goes berserk. And whoever wants to eat him goes, what? I thought you cooked it. You didn't cook it.
You see that giant sponge?
Yeah.
Aren't you worried about the really, 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 really big giant octopus that's in back of you?
Oh, I would love for that. That's one of my fantasies, by the way, is a giant squid attacking the vehicle and sub, and we get great video of it. But
How we get that on?
no, we don't worry about it. That sub has got a shell on it because it's a 1 atmosphere sub that's about that thick of steel. There's no animal that's going to bother us. The only thing an animal could do, a really big animal, could actually damage some of the instruments on the sub. And I don't know if you know, a couple of years ago, the Nautilus, the ship the Nautilus, had a remotely operated vehicle, and it was in the Galapagos, I believe. And they were down, and they were about maybe 500 to 1,000 meters down, and then some huge animal came into view, and they're all, nobody was in it. They're controlling from the ship. They go, "What on earth is that?" And it was a sperm whale, and it came right up to the ROV and kind of just nuzzled it a little bit like this, and then took off. And one of the guys at HURL, the Hawaii Undersea Research Laboratory here, was on that dive. He was controlling one of the ROVs on the ship Nautilus, and he was there in person. This is Max Kramer when that actually happened. And it is some of the, you should go on there and try to see it, sperm whale ROV, if you Google that. It's a really cool video.